evening. So my name is Winifred. I'm with Knight Piesold. So I'm going to be talking about better material characterization as a cost savings opportunity. So material characterization is a process we go through to understand the kinds of materials we are working with. So if we are building a tailing storage facility, we're going to be using some laterite or some rock. There's going to be tailings that we're working with. We want to understand how the material will behave. And he talked about how you go through the conceptual stage to the engineering design, to construction, operation, and then closure. So for the engineering design, that's where we need to have a lot of information to come out with a very good design. And to do that, we need to characterize the materials we're using. So we would normally do a site investigation. You go to site, have a look at the area, do a reconnaissance survey, do some drilling or test pitting, extract the materials you're going to use, do some tests on it, and then characterize it to say that this material is a clay or it's a sand, and so we use it this way or that way. And we do all of that. But this presentation is how we can do that better, because we've been doing it, but we want to do it better because we're talking about sustainability. And one of the ways to improve sustainability is to reduce our costs. And so how can our material characterization help us to reduce our costs? And that's what we're going to be talking about. So I'll talk about why we're talking about better material characterization, when, where, and how we can do it, and some real life cases in which we've achieved cost savings. So why better material characterization? As I said, we've been doing site investigations, and many owners and investors consider site investigations to be a sunk cost. That means they see it as lost money that you're never going to recover. And so they want to reduce the amount of money spent in site investigations because it looks like you are reducing your costs by doing that. Yes, however, if we all work together, if the owners, the engineers, the operators work together to characterize our materials better, we can actually achieve more cost savings. We'll spend a bit more on the site investigation and the testing, but in the long run, we'll make a lot more savings. We'll be able to come up with smaller facilities. We'll be able to have lower fill quantities. We'll be able to engineer different types of fills, fill materials, and eventually we'll have lower costs on the build. The most expensive part of building a TSF is the actual building of the TSF. Presently, it costs about $130 to haul material, to haul laterite, place it, spread it, moisture condition it, and compact it properly. And just for one truck, that's a tipper truck. You all know a tipper truck or an ADT. Just for one of those, it costs $130. So if we can save 10 of those trucks or 100 of those trucks, we are saving a lot of money. When we do better material characterization, we can see that your material is actually stronger than what we might assume. If we did a site investigation and we did maybe 10 boreholes and we're able to get good cores to do triaxial tests, we'll have actual strength parameters to work with. When we don't have a good enough budget to do a good site investigation, we have to settle for what we call conservative estimates. That means that we are covering our bases. We don't want anybody to come and say in 5 years' time that Knight Piesold did this design and now we are seeing failures. Okay, so we talk about strength of soils in terms of the phi angle, that's the internal friction angle, and the cohesion. So maybe the material has a friction angle of 26, which is very low. But we assume that based on this material, it looks soft. So we are going to assume that it has a friction angle of 15. What it means is that we are going to build a very big dam so that we don't collapse it. We are going to build a dam with a very mild slope, a very gentle slope. But if we're able to do good testing and know that actually the fire angle is 26 and not 15, we'll have a steeper slope. A steeper slope means we are using less material. If we did a tailings density test, if we don't do the tailings density test, we might assume that the tailings has a density of maybe 1.3 or 1.4. But maybe when we do the tailings density test, we'll find out that the tailings actually has a density of 1.7 or 1.8. So that means we can fit more tailings into the same space of a TSF. So instead of building a higher TSF, we don't need to build something so high. We just build a smaller TSF, and we can keep more tailings in it over a certain period of time. We also get to decide whether we can do an upstream raise or a downstream raise. An upstream raise means that we've built an embankment, we've built a TSF, we filled it with tailings, and we're going to build another, we're going to raise the embankment by building part of it on the tailings. So we have a smaller footprint, which is good for sustainability. It means we are not affecting too much of the environment. But if we don't know that our tailings is stable, then we don't want to risk using it as a foundation for anything. So we'll do a downstream raise. For that, you need a lot more material. You have to do another site investigation and all of that. So how can we do better? We can do better by investing in site investigations. Spend a little money now to make long-term savings. Expensive testing is expensive for a reason, because it gives us very good quality information. We can settle for very simple tests, and we'll get very simple results. It means we have to do a lot of correlations, use tables and equations and things like that to come to something that we can actually get from a test, which is more reliable. The other thing is that material characterization is ongoing. So during construction, we continue to characterize the material. During operation, we continue to characterize the materials. And it's not something that ends at one phase. It's something that you do from the beginning of the project till you've closed your TSF. And every component of the TSF presents an opportunity to save costs. If we characterize the foundations properly, it means that we can know if our foundations are strong enough to have a not so large embankment. If we characterize our fills properly and our tailings properly, it all provides opportunities for cost savings. What we can also do is to understand the goals of all stakeholders when we are designing the SI. So we all need to come together, the owners, the investors, the designers, to understand our goals and put together something that works for everyone. We need to do better characterization so that we can reduce the guesswork that we have to do, and overall will improve our processes and reduce our costs. So I'm just going to go through three projects in which we've actually saved a lot of money. So there was a large gold mine in South America. A design was done based on an assumed tailings density. And Knight Piesold was invited to have a look at the design. We did testing of the tailings. We got the actual density. The testing cost us $25,000, or it cost the mine $25,000. The redesign that we did based on the test results we had saved the mine $40 million US. They spent 25,000 extra and saved 40 million. You can do the math. That's a lot of money. And then also in North America, there was an existing facility that needed to be expanded. And it was going to be a downstream raise. So it would have taken a larger footprint. It would have needed more materials and that was going to cost a lot of money that they didn't have. And they also didn't have enough space for the downstream raise. So they did a detailed site investigation and found that the tailings is actually competent to support an embankment. So instead of a downstream raise, they did an upstream raised. And I mean, you could, just from the shape of what would have needed to be built, you can see that so much money would have been saved. And finally, a large gold mine in West Africa. There was limited SI because the designers felt they had experience with the area, they were familiar with the area and the materials and all of that. So a design was done based on that experience and familiarity with the area. Further investigation was done at the cost of $40,000. And based on that, they found that the fill material was strong enough and they could reduce the slope angle of the embankment. So instead of a 3-in-1 slope, they did a 2.25-in-1 slope, and they saved $1.8 million. So all of this is just to say that it may look like a site investigation is expensive, and it may look like it doesn't yield anything immediately, but in the end is when you see what you save that you could have spent. Thank you very much.